here we go. I've started the recording. This is our lecture for Design 350, first lecture of the week. It's Tuesday, November 2nd at 11 o'clock. We're on a Google Meet, and we're in the middle of our project number 1. It's week 2 of 2, and we've just got a bunch of stuff. Okay, this is our Hamul, San Diego County Foster Youth Tiny House Project. You're able to work in either Revit or AutoCAD, but my demonstrations are in AutoCAD. I did some work yesterday in the lab to show a little bit of Revit work, and we're going to do a little bit more today. Actually, yesterday was not much Revit work. It was looking at the letters of intent and things like that. And we've got a playlist, these project requirements, and I've added 2 things that we're going to go over today. The water supply options, which include the tank sizing estimate, so that you can sort of figure out what's going on from there. And then I'm creating this right now. So that'll be coming up. We'll talk about that when I've got it done. But some people like to get their final exam done kind of early. And so this will be kind of reading a survey record for this site and putting it together, reading theodolite readings, creating the survey record, and then putting the property lines around the site. Cool. So there we go. That's what we've got. So let's just get right into it. We'll talk about these water supply options and tank sizing of how to do that. So when we talk about having water supply options, I'm going to close one of these up. The first thing to do is you sort of need to go over right, what your level of use is going to be. Right? And so this was one of our designers, Josiah, put this together, and this is really where most of the work gets done. Okay, so he knows that there's going to be a toilet, a shower, some sort of lavatory and sink, maybe not both, maybe just one or the other, maybe a washing machine, and maybe a dishwasher. Okay, and so then the idea is to use all this and go, okay, well, what kind of toilet? I've got a 1.6 gallons per flush. I'm going to flush that thing 5 times a day. So it's going to give me a certain usage. And the shower is a 2 GPM shower. That's pretty standard. You type those in. If I put in a 5, you're going to see that everything changes. Okay, all that changed right there. Okay, and all this stuff changes. So, you know, and if I shower for 30 minutes, that makes a big change. Right? So into my total weekly gallons. Okay, how many showers per week? Maybe 2, maybe 5, maybe 7, maybe 10, who knows? So all of this calculates into how many gallons per week are going to be used. And that's important because you have to deliver that many gallons. And somebody is paying for it. And so this is going to get added on to the utility bill for this site. Okay. And so you can go from gallons to dollars if you know how much they charge per 100 cubic feet of water and know that there's, 6 point something gallons in every cubic feet. And so you can figure out, this is to figure out the cost. So again, in the gray, you would fill out what your numbers are. And then this is how much you would use if you had 1, 2, or 3 tiny houses, independent. Okay, now, I could see that you might have a washroom. Might just build a little facility that's got a washer in it. Because why does each one of those need its own washing machine? Right? And so there are some things that you could do to change this around. But right now, the ideas are 1, 2, or 3 separate tiny houses, and they're going to use this much water. Well, that's cool. That's your total water use per week. And you have to know that you can get that much water per week. Now, the next thing you have to know is, can you supply enough water if everybody wants it all at once? And so that's something called a fixture unit. How many GPM does one of these things use when you flush? Whoosh. Okay, and that's 1.6 gallons per flush, but they always list it at more fixture units. It's just the way it goes. That's just a standard, okay, that you design for. You can cut it down if you want. So there's fixture units. Okay, when that fixture is operating, how much comes out at once? And then you add them all up for the maximum possible flow rate. Okay, now it's very unlikely that all of that is going to be on at once. Okay, so usually there's some sort of a factor or some thought put behind it. So rarely would you, for instance, be using the toilet while the shower is running, as an example. Although it definitely could. So it could be that these get derated. Your customer needs to know about that. Okay? So there's a probable that you could put in here. Maybe you say, that's not all going to be working at once. We're just not going to do it. If you do try to do it, it's going to be a problem. So just show a little bit of care. So maybe you'll say, look, don't run the washing machine while you're running all this other stuff. So maybe you'll knock that down to 8 or 9. Okay, so you'll go 9, 18, 27. And so you'll design to one of these. Okay, you'll design maybe to the max, maybe to the probable, or maybe to something in between. You'll decide what you're going to design to. If it doesn't affect the design too bad, I tried to design to the maximum. Because then if somebody does need or want to use it, you've got the infrastructure. So my design, I'm going to say as an example, equals that. Okay, but now I'm going to undo all that. Okay, because you'll have a copy of this to work it with. Okay, so that tells me I'm going to need certain flow rate coming into this site if I've got 1, 2, or 3 different tiny houses. Okay, so there's that. Now I'm gonna size how big of a tank, because I happen to know that that site can only deliver 4 gallons per minute. We had them run a test on the site. They've got a hose up there, and they can get 4 gallons a minute. They turned it on and filled up a 5-gallon bucket in 1.25 minutes. 5 gallons per 1.25. 5 divided by 1.25 equals 4. So I can handle 4. Well, that's not going to do it. I need more than 4. So I'm going to need a tank. Okay, so let's say I want to meet that maximum demand, 37 gallons per minute. Okay, I want to do that one right there, 37. But I can only, if I have a hose and I've got a tank, I can only fill it up with 4 gallons a minute. So that means it's going to be dropping at 33 gallons per minute. And so there's one other factor called your demand cycle time. And that means how long will you have that maximum demand for? Or you can like take a break and just slowly let it fill back up again at 4 gallons per minute. And it's going to take a long time to fill that back up at 4 gallons per minute. So you might want to change that to like 5. Right? How long are you going to let people just do all that? Well, I mean, that's constantly flushing the toilet. You know, flush. That won't happen. Shower might. Sink? How long do you have to run your sink? A minute, 2? Maybe if your washing machine, maybe that's, but that doesn't do that for all that long. So this is a number that's really critical. How long do you think it's just going to really run that for? And so there's one more thing you could put on here. You could just say this is going to, how long will it take to fill up? It's going to take 40 minutes. So if you draw that down, you use everything that can possibly be used for 5 minutes, you're going to have to wait for 40 minutes for that thing to fill back up. Now, it's not really that bad. You know, it'll fill up 10, 15, 20 gallons pretty quick. And if you're not going to really use it hard. So this really is an estimator. How big of a tank are you going to need, though? 160 gallon, 200 gallon, 300 gallon. Okay, and then how much are you going to warn your clients? Don't use this too much. Don't just sit there with the shower running. You know, if all 3 of you are taking your shower at the same time for over 5 or 10 minutes, we're going to run out of water, folks. Okay, so that's what this is about. And you just have to decide with your client what that's going to be. You're going to just be able to decide. So I'm going to need, let's say I'm going to run this for 10 minutes. Okay, and I'm going to put this more like at 9. Let me come back to my tank, water supply, and I'm going to design it for 9 GPM. 9. So that's going to be 27 all told. That means I need a 230 gallon tank. 230 gallon tank. To be able to run 27 gallons per minute for 10 minutes. Knowing that I'm going to deplete it, but I'm going to be dribbling 4 gallons a minute into it. And this is to supply all of them. So now we've got this tank option, water supply options. I can put in some cool tanks. Here's a website for tank, a website for tank, a website for tank, mobile home website, tanks. I'm just going to go to this first one and take a look. There it is right there. And this is for pot farms. It's called 420. 420 water harvest. Okay, but here we go. 205 gallon. Not bad. That's pretty close to what I was looking for. Here's a 265. There's a 420. This one's kind of cool. Let's see what that one looks like. 260. It's kind of a cool one. That's what it looks like. And so you can put that on the pad, and it even, I don't know how many of these it's got. 2 or 4. 64 inches tall. It's only 25 inches wide. That's pretty cool. It's got a 2-inch bulkhead flange at the bottom. It's vented. That looks like a pretty cool flange. 265 gallon. There it is, right there. There's my dimensions. And these are pretty big. So you can, if that's a 4-inch flange, that's a 4-inch fitting, you know, that's big. You can put whatever you want on that. So this might be a nice thing, but now it tells you what size pad to build for it. You're going to probably want a little pump sitting there, but you'll probably put in a 6-foot by 3-foot little concrete pad to anchor this down onto. And you would, there's your overflow, and you would put your water in through here with a vent, or you could put your water right into here and put your outlet right into here. So not bad. So that's how you go about doing this. So there's just some good information for you. So where are you going to use that now? Okay, we've got, where are my drafting views? Project utility requirement. Project utilities existing. There it is. So your requirement, you're going to know that you have a cold water supply, and this is actually, it'll be able to do 4, right? It can do 4 GPM. And then you'll write down what your proposed demand is, what your proposed cycle is, and what your proposed tank size is. And then we'll talk about the sewage in a minute, but we just talked about that, right? And then on your project utilities existing, you would basically put in where the utilities are on the site. So you're going to leave this one blank because we don't know, but your requirement you're going to put in. Now, we have found that there is an existing septic system, so they want to put in a new septic system and a new leach field. And I have to, Josiah gave me the link to the proposed septic system, but you're just going to have to say that there is an existing septic and you're putting in a proposed new septic and that the leach field is identified. And that has to be put on your drawing somewhere. Now for power, they get their power from San Diego Gas and Electric. We need to know the amp service We don't know it. So you're just going to put in, who knows what it is, 100, 150, 200. We don't know. You'll just put XXX. Now, I believe that they want to put in solar. And so we're just going to say that they're going to put in a certain amount of solar. And that's going to leave them a certain amp for their new service. And again, we don't know those numbers. So you're just going to put it in there just like this. A lot of these are still going to be placeholders. Okay, so now let's come down, look here. Those were on the proposed use case. So this now fills in. Let me start from the top. Let me look at project proposal. I've now filled in the project data. This information comes from what we talked about yesterday. This comes from your letter of intent. List the principals, who's paying for what, who will own stuff, who are the designers, and who are the contractors. That will go here in a box. List the purpose. Very straightforward and simple. And then your description. So that's what we went over yesterday. And then here, you'll put the address, the owner, the acreage, and the zoning. You can also put down, if you want, the existing residents, the existing buildings, if you want. After the address, you can put one residence, X number of square feet, one garage, X number of square feet, da-da-da. Okay, so that takes care of your first page. Your second page just does itself. Project zoning, that's going to come from the work that you've got in your discussion board. Leah put up a ton of stuff about the zoning. So you're going to look through that information and put down here what the current zoning is, what's allowed, how big the site is, all that kind of good stuff. So that goes in your project zoning. Your similar projects, again, Leah posted that into the discussion board last week. So you're going to list the similar projects and you're going to put the map together, much like the local services. You're going to show your vicinity, and right up here is I think it was near El Cajon, right? Or just north of El Cajon. You're going to put where the similar one is. So you're going to have something that looks kind of like this, but you're going to show where that similar project is. And this you're just going to leave blank. That's going to be to be determined. So you're just going to leave it blank. But you've got the information to do this, project zoning. You have the information for this, similar projects. I just went over what to put into your project utility requirements. Your local services we did last week. Similar project map from the discussion board, and this stays blank. Your compliance statements now, you have the information to start filling this out. Okay? And remember on mine, I put in 3 parking places, but I've got a driveway and a garage from the other one, so I have to add that all together. Okay, so this is your existing. Garage and driveway existing, and this is your new proposed. These areas you just measure and take, measure, count them up, count them up, count them up. So this is stuff that you can just do. So this one gets filled out. This one you can just do. You look at that data that Leah and I think JR put some on there. Look it up, and you don't need a proposed variance for this. You don't need one. Now, this is an interesting one. I think this does expect to utilize federal funding because the nonprofits or the state funding that helps out foster youth also will be getting funds from federal. So you're probably going to change this to yes. And so you're going to need to list the AFFH requirements. And we've done that in the weeks past. And you even did it in your midterm and your Nearpod. So you'll list those out right here. So this one you have information, you have information, you have information. We don't really know what the San Diego Council of Governments funding plan looks like. Oops. But if you were to go look that up, you could do this, but you can leave that one blank. You can leave your CC&Rs blank because we don't know what they are. And you can leave the local commissions blank because we don't know what they are. So this bottom row, you can just leave as is. And this top row, you can fill in. And that's just looking information up and typing it in. Existing site plan we worked on. Existing topo and drainage plan we worked on. Proposed site plan we worked on. And now you can sort of see why this has a certain size. Right? I'm going to need to put that tank somewhere here. Now, it could be that since it's not too big, I could draw it in maybe a little closer and bring it over here. So I can still do work on this to make it better as I'm going along. So maybe I want to come in into here, and I know that I was really more likely thinking about putting in a pad here. Oops. What did I say it was? It was 3 feet. Three by five. Oh, 5. And that one was going to be blue. And that's really the size that I'm going to need for that. And so I can put it in a pretty nice area where it's easy to get to. Right? And that takes it out of this area so I can bring that around like I was thinking. So I'm going to take that out. Should be able to rotate that. There we go. That's a little better. Okay, so that gives me that, and then we don't really know where this is going to go either. But if I felt like it, I go, well, that makes more sense. Getting that somewhere else. Okay, and that's a pretty big pad for the electrical. Really shouldn't need to be that big. This one's kind of maybe in the way here now that I look at that because I want to be able to get this in. So I'm always thinking about what can I do to just make this a little bit better, a little bit better, a little bit better. And that pad is huge. How big do I have that pad? 13 feet is gigantic. You know, if that thing is more than 4 feet, probably by 2 feet, that's more like the size of electric utility pad, right? They're just not that big. And I can rotate that. So I'm always trying to think about what makes sense to make things a little bit nicer, a little bit better. So now it's easier for me to run my utility. And I didn't do a very good job rotating that, did I? Well, I'll get that back rotated. There we go. Let me do a better job rotating that. There we go. And so slowly my design starts making a little more sense. Right. And I can continue this around and stuff like that. I wonder if that lets me do that. Nope. I have to make another one to do that. Okay. So that's just some minor improvements that now that I know how big this is getting, and I would probably put a meter on here, and I can either meter each one of these, or I would just put the meter on whatever is filling up my tank. Cool. So there's another little thing that I can do. Just going through making this better and better and better as I go. There's my existing site plan, topo and drainage. That's what I love about Revit. This is now fixed up. Stormwater pollution plan. Most of what I saw looked really good on these. You're doing a nice job on them. Same with the topo and drainer. Now, the proposed water plan, power plan, and mechanical plan, I'm going to leave those blank for now. If we get to those this week, that will be okay. But I'd rather have you spend time on getting these detail sheets done. Okay, so make sure that you can get these two detail sheets done. And your letters of intent and things like that. Okay, and once you've got these sizing calculators, okay, you're going to want to make a copy of this, and this will be along with your water supply options. You can print this out. These will go along with your submittals. Now, the last part is your pump supply. Okay, so you can see that you're probably going to need to pump between 12 and 40 gallons per minute. Between 12 and 40. Well, this one will pump 12. This one will pump 30, 15, 15. So you know what? Right off the bat, you're gonna be maybe limited unless you put one pump feeding each tiny house. So that's just something to think about. How am I going to do that? How will I do this? And probably you're probably going to do something like one for each tiny house. But this has to be kind of known. And it's not too hard. You can put 3 of those right in line. They're not too big. There it is. Let's see if it shows how big it is. Yeah. Features. It's a 1 1/4 inch, so that's good. Ideal for rentals. 1-inch discharge. 230 volts. That's a little bit, I think it can run at both. Yeah, so it can run, but look, it's going to take 6 amps, 12 amps. That's pretty heavy duty. So while that's running, it's going to be taking some oomph. But it won't be doing that much if it's not using that much. So there's a whole bunch behind this pump stuff. It's got a pressure switch so it won't overgo. Oh, that's only 12 gallons per. Well, this bothers me because this says gallons per minute and this says gallons per hour. This has to be a mistake because a 3/4 horsepower wouldn't do that much. But anyway, you can just pick one of these. You can just pick one of these and say, yeah, I'm gonna pop that down right there. This one's maybe a little bit more hefty. Let's see what this one does. That's a pretty hefty little pump. It's nice. It's got a little return on it. It doesn't need continuous operation, so this one's a little bit overdone. But this gives you a few things that you can look at also if you want to go that far. So if you were to do so, you could in your detail here, that's that thing right there. That's the pump. This is the tank. This would feed into the tank. So you could take this and identify some of these items. That's your pressure pump. That's your water tank. Good to have an inline filter. There's your power. Okay? So hopefully you're hearing all this and it's sort of making some sense. You can just copy this out and trace it over. It's a typical, but as you go, you're getting more and more and more for a complete package. Okay. There we go. I think that's mostly what I wanted to go over for today's lecture. Water supply options, tank sizing. There's your project requirements that we've gone over. Letter of intent we went over. So I think you're pretty well set to just be able to work through. Um, Hopefully by tomorrow, I'll be able to talk to you about your alternate final exam, which you can do early if you want to do so. I should have it mostly ready, at least for the first part of it. And so we'll talk about that tomorrow or Friday. And other than that, it's just put this stuff together. The ones that I've seen are looking good. Keep up the good work. Just keep plowing this stuff in here, and we'll finish putting it together. So, any questions before we turn it off? Okay, then I'm going to go ahead and stop the recording.